How does gravity affect the difference between weight and mass? Have you ever wondered why you feel lighter on the moon but weigh the same on Earth? This question leads us to the fascinating relationship between gravity, weight, and mass. Let's break it down in simple terms. First, let's clarify what we mean by mass and weight. Mass is the amount of matter in an object. It remains constant no matter where you are in the universe. If you have a mass of 70 kilograms, that number does not change whether you are on Earth, the moon, or even in space. Weight, however, is a bit different. Weight is the force that gravity exerts on that mass. It is influenced by the strength of the gravitational pull in a given location. So, when you move to a place with different gravity, your weight changes, but your mass stays the same. To understand this better, we can look at the formula that connects weight and gravity. The formula is weight equals mass multiplied by gravitational acceleration. This means that if the gravitational pull is weaker, like on the moon, your weight decreases. For example, on the moon, gravity is about 1/6 that of Earth's. So, if you weigh 70 kilograms on Earth, you would weigh only about 11.6 kilograms on the moon. Now let's consider what happens in a stronger gravitational field. On Jupiter, for instance, the gravity is much stronger than on Earth. If you were to stand on Jupiter, your weight would increase, but your mass would still be 70 kilograms. Astronauts provide a great example of this concept. When they are in space, they often feel weightless. This does not mean they have lost mass. Instead, they are far from Earth's gravitational pull, which makes their weight effectively drop to zero. In everyday life, we measure mass in kilograms or pounds, while weight is measured in newtons. However, scales often show weight in units of mass because we are used to Earth's consistent gravity. Understanding how gravity affects weight but not mass helps clarify many common confusions. It also has practical applications, like calibrating scales for different environments or designing spacecraft that must consider weight changes during launch and orbit. So, the next time you think about weight and mass, remember that gravity is the key player in this relationship. It shapes how we experience the world around us and helps us understand the physics principles that govern our universe.